In the previous session, we saw how observing patterns and framing rules are connected with algebra. In this session, we're going to learn the language of algebra. And by the end of this session, we would have learnt various terms of algebra and how to write algebraic expressions. Algebra uses literals that represent numbers. A, B, C, X, Y, Z are some of those literals. The value of these literals vary from problem to problem, and so they are also called variables. Recall the formula for the perimeter and the area of the rectangle that we saw earlier. Perimeter of the rectangle, P, is equal to 2L plus 2W, and the area of the rectangle, A, is equal to L times W. P, A, L, W. These stand for perimeter, area, length, and width of any rectangle. Hence we can say that literal numbers are used to represent general statements symbolically. Therefore, algebra is also called generalized arithmetic or general arithmetic. All numbers like 3, 2, -7, -15, these have fixed numerical value, and hence, they are called constants. All operations are numbers that we do in arithmetic can also be done on variables in algebra, as these are nothing but changing numbers. Now, let us look at some examples for operations on variables. The sum of x and y can be expressed as x plus y. 7 added to x can be expressed as x plus 7. 3 more than y can be expressed as y plus 3. The difference of j and k can be expressed as j minus k. The product of 5 and x can be expressed as 5x. 3 times a number y can be expressed as 3 multiplied by y. 5 taken away from the product of x and y can be expressed as xy minus 5. The quotient of 7 and x can be expressed as 7 over x. Half of m subtracted from the product of k and l can be expressed kl minus m over 2. Product of 4 and y divided by the difference of 5 and y is written as 4y over 5 minus y. Now, let us understand the powers of literal numbers in arithmetic. We write 4 times 4 as 4 cubed, and 7 times 7 as 7 squared, and 6 multiplied by itself 5 times, we can write as 6 power 5. Similarly, we can express algebraic terms as d times d, as d squared, y multiplied by itself 5 times as y power 5. So, an algebraic expression can contain powers of variables too, along with all the 4 operations. For example, 3 x squared plus 4y z plus 6 is an algebraic expression. Consider 2x, 5x, 7x, minus 9x. These are the products of x with different constants. Nevertheless, they are all terms involving the variable x, and so are alike. Hence, they are called like terms. 3x, 4y, 3l are with different variables, hence they're unlike terms. Now, let us see what are factors and coefficients. Let us take the term 6y. We know that this is a product of 6y and b. Here 6 is called numeric factor, and y and b are called literal factors. In algebra, we call any one of the factors as the coefficient of the product of the other factors. In 6y, 6 is the numerical coefficient of y. 6y is the coefficient of b, and 6b is the coefficient of y. In -m, -1 is the coefficient of m. To understand factors and coefficients better, let us look at some examples. Find the coefficient of xy in -5xyz. Yes, it is -5z. The next example is, find the coefficient of the variable that has the least power in -3 y power 8 times b power 5 times c. Can you find the answer? Yes, it is c, which has the least power, that is 1. And its coefficient is -3 y power 8 b power 5.